Everyone, it's me, Prabodh, uh, a PhD candidate at the Department of Civil Engineering. Mm, Today, I'm going to demonstrate some basic tools and modeling methods in Abaqus. I'll be taking one example problem of steady state heat conduction. Actually, I've used Abaqus extensively for my research work, so I have a feeling that I would be able to demonstrate it properly. So I have selected one problem. It's a problem of typical heat transfer model. So I'll be demonstrating the modeling and analysis procedure for 2D continuous system. It's a boundary value problem, BP. So I've selected this structure, this segment of structure actually. So it's nothing, just a brick wall of 0.25 feet width and 0.5 feet height. It's made up of brick. That means you have to select the thermal conductivity of brick, which is 0.00121 in the unit system we are doing. So I'm going to start here. So I'm just opening Abaqus software, Abaqus CAE. So after you click it, this screen will show up and it will give you some information of licenses. Let's go. Then here, so you'll have two options for creating the model database. We're not doing anything for electromagnetic model. We're just creating standard or explicit model. So I'm using this one. Okay, then this screen will show up. Before starting, I just want to give you some information that would be very useful. You can't ignore. Actually, it's about the unit system in Abaqus software. Actually, Abaqus work on consistent unit system. You'll never ever notice the units here, but you have to be aware that you are using the same unit system throughout the analysis. Let's say if you are using meter for length, then you should use meter and any other quantity that have length in it. For example, if you are using Newton for force, meter for length, then you have to use Newton per meter square strictly for elasticity or stress values. You cannot use Newton per millimeter square, otherwise the Abaqus will get confused. And I don't think you are gonna put some confusion for Abaqus software. So let's start. First thing, what you have to create is parts. Since it is a wall system, right? So you have to create a wall. So it's a 2D structure, planar structure, right? So with thickness 1 feet, that means unit thickness. You have to create a rectangle of this width and this height, right? So here we go, parts. So in part, just name it wall. You are creating a 2D planar structure because you have unit thickness on another dimension, so 2D planar. If you are going to analyze 3D structures, let's say a space frame, then you have to do 3D structure. So you are going to use deformable because you are allowing it to deform. And cell structure, so cell is a plate-like planar structure with small thickness on another dimension, where it's just a line, point means just a point, so you need, and you are creating a wall with one thickness, right? So it's a fit because you are using fit dimension here for length. So you're gonna use fit everywhere where length comes in. So continue. So this screen will show up, and here, so you have to create a rectangle because it's a rectangle wall, and I'm here demonstrating you with the help of coordinate system. So if this is your center point, this is your origin, then this coordinate is gonna be 0.25 x coordinate and 0.5 y coordinate, right? So I'm gonna use a rectangle. So here it's showing pick a start corner for the rectangle. Then you are gonna use just 0, 0. It's in form of x comma y, so 0, 0. Okay, so it's asking you to pick the opposite corner for the rectangle. So it's gonna be 0.25 comma 0.5, right? So what I've done here is this is your 0, 0 point, and this is your 0.25 width and 0.5 height point, right? So then press enter, then this will show up. You'll get this one. So it's a rectangle of width 0.25 and height 0.5 feet. So always be aware we are using feet, right? Okay, then just do it here. So select sketch the section for the planar shell. So we have completed creating a section. So just press done, then a wall of your required dimension will show up. Then next, what we're gonna do, first look here, you'll be able to see wall section. So it will appear here in part. So if you have to do multiple parts, then you have to create the parts individually, then lots of parts will show up. If you are attaching a beam to column and slab, then you have to create beam, you have to create column, you have to create slab independently, then it will show wall, or let's say slab, beam, and column here, right? I'll be demonstrating that frame system or a complete room system later during the probably last or second last week of this semester, so don't worry about it right now. Okay, then we have successfully created our part wall, right? Now the next step is creating a material definition. So we have to create the material, and we have to assign the material to the wall, right? So material, so what we're going to use is brick, right? So name it a brick. So I just got this dialog box by double clicking on material. So brick. So look here. So if you are inputting different parameters like the density, let's say elasticity, electromagnetic, then you'll get these options here. But now our only concern is conductivity, since we are doing the heat transfer, right? So I'm just using conductivity parameter. So you do not have to worry about it here. So you'll get different types of material based on its properties on different directions. So we're just using default. So if we are doing or simulating fire, or let's say some thermal stuff, then we have to be careful about it, and we have to use temperature dependent data if you are going to use that one in your investigation purpose. So now I'm leaving it default, so whatever it is here, leave it here. So now conductivity. So what is our conductivity in this survey? So I just need to go here. So okay, So conductivity, so it's 0.00121. So we are using feet as our interval length, right? So it's for feet square, so we can use this unit, right? So it's 0.00121. So 0.00121. Look here, you'll not see any unit here, right? That's why I just told you have to be consistent with the unit. Okay, so conductivity. Okay, then you'll be able to see your material definition brick with conductivity you just provided. Okay, then you became able to create a material definition. Now you have created material, you have created parts. Now what you have to do is assign this material into this part, right? So for that you have to create section first. So okay, let's go for section. So what's the section name? Wall, right? Wall section. So you can name it whatever you want. Just make sure what material properties you are using. Just I'm assigning a solid section, and it's section, right? It's not a part, it's section. So I'm assigning a solid section. I'm assigning it to be homogeneous. And it's like consist of same properties of material throughout. So okay, now you can see here. So here brick appears, but listen, if you have lots of material in here, then you'll see from this drop down menu lots of material will also show up here. So you have to select a particular material, but in this case we just have one material, so it's okay. Just selecting brick. We're using this default. It has some meaning, but in our case it's just like you don't have to worry about it, right? So you can see here you can assign material from here as well, right? But we have already assigned the material, so we're using the material assigned or created before. So okay, it's okay, right? Now what you have to do is just click here, wall. Now whatever the things you are going to put for the wall will show up here, right? So section assignment. So for wall you have to assign the section assignment. Double click here, then it will show here. So what it is saying is select the regions to be assigned a section, right? So what are the regions? So this is only the region we have. So I'm selecting this one, and it will show some purple edges with pink background, pink solid. So I'm just using done. So the main thing here, look, if you have lots of sections, lots of material, lots of parts, then it would be easier to create a set. So if you want to be organized and you don't want to be confused later on while assigning different sections to the different parts, then it will be better if you create the set, right? So I'm not creating set. Let's create just one set wall. So done. Then what section you are going to assign? It is automatically showing up. However, if you have lots of sections, then you have to select from here as well. So assignment from section, it's okay. Okay. Then now, first it was just a wall without any section. Now it's finally a brick wall, right? So it's a brick wall. Now you are now able to create a brick wall with brick material of required dimensions. Now the thing, what you have to do is you have to assemble it in a model. So you have successfully created a part, not the model yet, right? So for model, you have to include furthermore things. So okay, now the next step. After creating a part and assigning a section to that part, what you have to do is you have to go for assembly. Look here, you'll see the assembly. Now you have to assemble. Actually, how assembly menu work is with different parts. You have to like assign the orientation, you have to connect the parts, and then you can build a model, right? But here, since we just have one part, you can easily do here. So assembly, double click the instance, and it's showing create instances from parts. So just one part is showing, leave it other thing default, then just do apply. Okay, sorry. So then you have already created one instance in assembler, right? So while what is showing now, you have assembled, now it is a model. Okay, then you have created a model, right? Then what are other things your model have? Look here. So you have created this one, right? Now, since it is a boundary value problem, BVV boundary value problem, you have to assign the boundary conditions, right? So what's the boundary condition here? It's external temperature outside the room of 100 degree Fahrenheit, and inside is 70 degree Fahrenheit. And all the bottom and top edges do not have any heat flow, right? So it's Qy equals to 0. So you have to assign the boundary condition here. Okay. So to run any analysis, you have to create a step. So here you can see steps. So you have to create steps, right? So just double click on a step, then just click your step is heat transfer, right? So here, like, so you have got lots of procedures here. So if you want to do like a static general analysis, like just looking at the shapes or beams like you did on statics, it's just like apply load, look at the deformations, you can do this analysis. If you want to do dynamic analysis, if you want to do some coupled analysis, you can look at here. But now the only concern is heat transfer, right? So select heat transfer, continue. Here, look, we are doing this steady state transfer problem, right? So what it says, steady state conduction, right? So it transfer problem. So we are selecting the steady state. Okay. Okay. So documentation, just leave it default. This is one of the important thing that you have to take care while you are running some high level simulation, but here just you can put it whatever it is in default. So okay, now you can see your step heat transfer is showing up. So okay, so you have created heat transfer steps successfully. Now you can apply the boundary condition from here. Just look here, boundary conditions. So what are the boundary conditions? So it's the temperature at left side and temperature on right side, right? So temperature on left side and temperature on right side. So temperature, so let's say left temperature, right? So continue. So it's asking you to select the regions for the boundary condition, right? So let's select not whole, just the left edge, right? Okay, select it. Let's say left. Done. So this dialog box will appear where you have to input the magnitude, right? So what's the magnitude? 100, put it 100. 100 is Fahrenheit, right? You haven't used any magnitude of temperature before, so Fahrenheit will be fine, but you have to make sure if you are running it or taking it to further analysis, then you have to be aware you are using Fahrenheit for every temperature cases, right? So okay, do it. So left boundary condition is set. Now similar, another boundary condition, let's mention it right here. Continue, let's put it right, create set, just select the edges, done. So right temperature is 70, right? I think it's 70. Oh yeah, it's 70. And okay. Okay, so now you have successfully created temperature here, boundary condition. Now the next step, now before starting any analysis, you have to create the mesh. That means you have to define the nodes, right? So here, just go to the mesh here, or you can do it from here as well. So what you have to do is select the element type. So you have to assign the mesh to this given problem. So analysis, I'm sorry. Okay, so analysis. Okay, it's saying dependent part instances cannot be edited or assigned mesh attributes. So this is one the thing that usually comes when you do not make your part independent while creating an instance, right? So now I'm doing it here. So what you have to do is, here you can see, right, in the instance there is wall, right? What you have to do is make independent first, right? So now your wall is independent, then you have to go to mesh and element type, right? Go here, select the regions to be assigned the element types individually. Just do it individually here because you do not have any other elements except the wall. Done. Here, look. So element library, standard, geometric order, standard, just put it default. What you have to change is the family. So it's what kind of procedure we are doing. So it's this transfer, heat transfer. So put it to heat transfer, then do okay, right? Then you can make it done, right? Now, again, you have to seed edges, right? So seed edges means you have to assign the mesh through the edge, right? So you have to seed edges, you have to divide the edges into parts. So select this edges, right? These are the edges, and you have to divide the edges to create a mesh. So select the region, select it, to selection, selection, selection. So yeah, remember here, if you have to select multiple parts, just press shift and select simultaneously. So it will like add selection, right? First select one part, then press the shift from your keyboard, then click on another part, then the first part you have selected will not be lost. It will be added on the selection, right? So I selected the 4 edges and done. See here, how we're gonna assign your local seed is, look here. So what kind of problem or what kind of mesh you are trying to create? So it's like you are dividing this wall into 4 parts, right? 1, 2, 3, 4, right? So how many elements you are trying to create? On edges, 1 element, 2 element. Here as well, 1 element, 2 element, 1 element, 2 element, 1 element, 2 element. So just do it by number and put the element number of elements to 2. So okay, you can apply it, right? Look here, you can see 1 element, 2 element, 1 element, 2 element, 1 element, 2 element, 1 element, 2, right? So okay, now press done. Now the main thing is creating a mesh. You can do it from here, right? Miss part, or you can do it from Christmas. Create miss part. So do it from here. So okay, to miss the part instance, yes. Then you'll get 4 elements on this wall, right? Now you have completed meshing your wall. Now look here, you have created a wall of these dimensions. You have assigned brick material into the wall section. You have restricted the boundary conditions by putting the external temperature to 100 degrees Fahrenheit and internal temperature to 70 degrees Fahrenheit. And you have provided the conductivity value to the brick, and you have meshed it into 4 elements, right? Now the final thing is you have to run the analysis. Okay, so look here, your boundary values are set. You do not have any loads, so you'll not have to worry about it. But if you have to do an analysis requiring the loads, then you have to input the load from here. I'll be demonstrating this one in next example afterwards. Now the final thing is you have to create a job. Just double click it, right? Just name the job with transfer. Okay, you are transferring this job to this model. Okay, continue. Now it had some meaning, like these tabs always have some meaning, but you don't have to worry about it right now. So I'm not going to describe these in details. Just put it as default and do okay. Then you'll see the job you created here. So it's saying heat transfer job. Now first you have to check your data. So let's say, right, just click okay, whatever was there, because all these things that are showing sequentially do not have any meaning. So I just clicked okay on them. So after you did a data check, then it's showing check completed. So you can see here the input file processor completed successfully. Then all these data check are completed successfully. If you have got some errors, it would have shown here mentioning, like if you have forgotten to assign the sections, then it will show your sections aren't assigned properly. If you have forgotten to do the meshing, then it will show you haven't done any meshing. If you have forgotten in boundary conditions, then it will show automatically. Then you have to do whatever is showed and again run the analysis. However, you do not have any error right now, so I'm just proceeding further. Now the final step is submitting the job. So do submit. Okay, I'm submitting the job. Look here, it's showing running. Now it's completed, right? So you have successfully completed the analysis. Now what? You have to look at the results, right? Now the results, you can right click here, then it will show up, then results here, right? So it's your results tab. Look here. You can look at the deform shape. You can look at the contour. So it's saying HFL. The only thing you are analyzing is, and it's the temperature profile. So it's your primary variable. So you can select here and you can see a contour. So you can just click on here and look whatever is desired. So it's animated thing is saying a contour over time, but you do not have to do this right now. So you can, whatever you can do is just, so this trace contour. So look here, oh, sorry, did it here. Okay, I just have to do it. Oh, okay, it's saying restate time zero, so it's initial, so you have to click here. Okay, that's your temperature profile, and that's what is required and what I am doing the analysis for. So you can see the temperature profile. So it's starting from 100 degrees Celsius to, oh sorry, 100 degree Fahrenheit to 70 degree Fahrenheit, right? So it's in the temperature profile. Okay, that's all what I was trying to demonstrate. Now here are lots of menus. These menus are for plotting your data. So if you are plotting any data for, like, let's say particular parameter, temperature versus time or temperature versus weight, then you can just click here. Sorry, extra data. Then you can like put anything here and you can do post processing further. So I'm not doing anything right now, and I don't think you are required to do any post processing. Just it is up to what I wanted to demonstrate for you. So that's it. If you have any questions, or if you have any confusion regarding the tutorial I just demonstrated, just email me on this address, or gmail.com. So you can email me on any of these two addresses, and hopefully I'll be able to resolve your problems. And I'll also be sharing this document that has some stepwise procedure for your analysis. So I tried to make it as elaborative as I could do. So I think this will be able to answer all your queries, and you'll be able to learn much more from here. So these all are the screen captures of the processes I used and I discussed right now. So thank you, stay safe, and have a nice day. Okay, bye.